If you make it hard, then we are wrong. So we know that. Let's go. All we have to do is put it in that particular order. 3, 2, 1. The Facebook Live took a bit of time. Okay, now we're live. Right, it says, here's the thing. What is the aim? Let's put aim. That's the first thing, the first part of any experiment. You need to tell us your aim, the aim of the experiment. Then after we put the aim of the experiment, then we are going to put the variables. Remember, we have independent variable, dependent variable, and we have the control variables, which we should keep the same. So don't forget that part. Right? We start. Aim of the experiment, write for me the aim, is to the aim of the experiment is to investigate how light refracts, in brackets you say bends, when passing through, then I want you to say 1, rectangular block, 2, semicircular block, 3, a prism. 3 will be a prism. Let me say this. One of the easiest things that people fear is refraction. When we talk about waves, you should know that when a wave, energy is moving, right, in a wave, when it gets at the boundary between two media, so this is just a boundary where something ends and something begins. So we say this is the boundary, right? We have the media in plural of a medium. When it's one, we say medium. Medium number 1 when we study waves, it's somewhere where a wave passes through. The first medium is going to be air. Then the second medium that a wave can pass through, medium number 2, is going to be, so number 1 is air. Medium number 2 is going to be water. Then medium number 3 that you meet at IG is glass. Right, so we have a wave, particularly light waves, right? And what this wave is doing is, it is moving for reflection. It will go exactly the same way it came in, but in the other direction. So either it will reflect, it will pass through, or it will reflect, or it will be absorbed whilst trying to pass through. So it will be absorbed. Let's say it's light, it hits your skin. It's not going to pass through. It's going to be absorbed. But when it passes through, okay, let's say this is air, and let's say this is water. We will want to know, you're going to be better at refraction. You will be better at refraction. Don't worry about it. You're going to be better at refraction when we study the idea of refraction, to say when we have air, when we have water, when we have glass, which one has a higher refractive index? Like, how do you know when it comes, for example, let's say from a ray is coming from air and it is going into water? When it gets through, when it gets at this boundary, when it's passing from air to water, does it bend away from the normal or does it bend towards the normal? You want to know these things. Let me explain. When you are doing refraction, basically the concept is this, so that everybody just knows the basic concept. Boundary does not matter. When we are doing reflection and when we are doing refraction, refraction is bending of light. We just want to prove that when light is passing from air to water, or even through a prism, your prism could be a glass prism. You see, your rectangle is a glass. It's something. It's made out of a certain material. And air is coming, and your wave is coming from air, getting into this material. So we want to know, what you must know is that your ray does not pass through straight like this and continue the way it was moving. This is impossible. It is going to bend. It is going to bend. Are we together? So, are we together? So it will either do this or it will do this, but it won't continue straight. So this is what it would have done if it had continued straight. You should put what it would have done, right? But it will now go like this, okay? Or it will now go like this. Some form of bending. So so this is refraction. It's just to say a ray does not continue straight when it passes from one medium to another. That's refraction. It will bend. So if you wait for it here, you are going to wait forever and you're going to get old waiting for it. You will not find it. Yes, I see a hand is up. Yes, you can ask me the question. Yes. Yes. All right. That's the very, 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 very important question. Yes, I see another hand is up again before I answer this one, because the question for Uratele is which one is denser? If we're using density instead of refractive index to say air, water, and light, which one is denser? Yes. Ask me the other question. The other one who raised their hand before I answer. Ask me the question. All right, let me explain. Since no, it's not. It was not a question. Uratil, I want to get something out of you guys as my students today and forever. When you are doing the topic of waves and you see the word density, it is what they call in physics optical density. Like, it's not the density we know of mass and volume to say something is heavier, you know, where we say denser. So it's not the physical one, the physical density. No, 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 no. Like to say when something is physically denser, it means it's heavier, right? So dense means it's small and heavy. When you are very dense, that means you are very small and you are very heavy. But now, when we say density in here, it's true, there is the word density, and you must be able to use it. But know when you are using to say this is density to do with its optical density, okay? It just means when something we say it is denser, it just means it has a higher refractive index. It bends light or it slows light more. Are we together? So if something is dense in waves, students, if you are in waves and you say dense, it means it has a high refractive index. And if something has a, I'm already now teaching you refraction, but I was going to teach you later, but it doesn't matter. If something has a high refractive index, it means it will slow down light more. So if something is going into a more dense, then that means it is going to bend. Now let me show you how we make it bend. Well done, Uratele, for this question though. This is, you see this point where your ray meets the boundary. Put a normal line, a 90-degree line, which passes through that point. Okay? So let's put it. Right. This one, this normal. So this is going to be your normal. So we know that if the ray had continued, it would have continued exactly the way it met the normal. So it could have been just like that. But now it is going, let's make it even better, like it hits like this. All right. So now what we would do, this is your wave coming in. Either it's, remember, this is the normal path if it continues straight. This would have been the normal path here. Exactly the same way it came. But now either it will bend towards the normal or it will bend away from the normal. Right? Now, you understand? If now it is, so you just need to know that when I am coming from, so for example, this is air to water. Water is more dense than air. If we are putting density, optical density, things that we use, we say air is the least dense. Then there is water. It is more dense than air, but it is less dense than glass. So this is the most dense, which means it has the highest refractive index. Yes. Oh, really? Okay. Can everybody see the boundary? So, this idea of refraction, what is it all about, class? What is to refract? To refract is to bend, right? It means it doesn't continue on the same path it was moving in. When it moves from one medium to another medium, it can never continue on the same path. Are we together? So, here is the normal line. So now the concept becomes, here is how it bends. This is refraction, which I'm teaching you. Then I'll come back to this experiment. We know that it will get to the boundary and bend either like this, which means towards the normal, okay? Towards the normal. As compared to what it was supposed to be, it can now bend towards the normal. Or it can bend like this. So it came in like this, then it will bend like this and move away like this. This is away from the normal. So we want to know, where should we expect this ray? This side or this side? You look at where it's coming from and where it's going to. Here is the concept. Let's finish it once and for all. This air is the least dense. Is everybody on the same page? Lowest refractive index. We want to now see how it bends. So we are studying the three media that they can give us. This is a medium, this is a medium, this is a medium. Together we call them media, like this. So let's study the three media that we have here. Come on now. We have air, we have water, we have glass. Who is the most dense of the three? Students, between air, water, and glass, who is the most dense of those three? Tell me now. Who is the most dense? It's glass. Then followed by who? Followed by water. Then who's the least dense with the lowest value for N, refractive index? It's air. Air has the lowest value for N, the refractive index, so it's the least dense. But this is not the dense of heavy. It's the dense of optical density. Still, it's fine. Whatever you think about, if it's density for heavy, whatever. Now we come to the next thing now. We are saying, listen, when you move, here's the rule. From less dense to more dense. Wave slows down. And when you slow down, it will bend towards normal. So I don't care what medium you are moving from and to. If it's less to more, which means air to water or air to glass. If you're coming from air to water or air to glass or water to glass, That means you're moving from less dense to more dense. Your wave will be slowed down. It's getting into a more dense medium, and it will bend towards the normal. So it will come closer. So this will be the new path of your wave. Now you can remove this one. So this should be your final solution, something like this. It should have gone like this, but it went like this. So it's closer to the normal line. So it bent towards the normal. So you put it, like this. So this is your new ray. So it's bent towards the normal. That is from less to more dense. Are people on the same page with me here? Okay. Now, let's go for what happens when you come from a more dense medium to a less dense medium. That is all you look at. You should know their densities to say this is the least dense, this is medium, and this is the most dense. You should know that as an IGCSE student. Come on now. You should know who's the most dense, who's the least dense. You should know. Now, from more dense to less dense, what happened? The wave speeds up because it's now going into a less dense medium, and it will bend. It bends away from normal. This is an important statement. It bends away when it gets to a less dense. So if we spin this and we say this is glass to water, then your wave, which was supposed to have continued like this, is now going to bend like this. This is the new path of the wave. Yes. Is it load shedding? Is it load shedding? Oh, okay. Okay, I'll give you a ring. I'll give you a ring. Okay, Hwaba? Hwaba, I'll give you a ring. Right, we continue, right? Should we continue? Right, we'll go to next. So it bends away from normal and it bends like this. Is bending. Students, you can say it's bending. That's refraction. There is no other refraction. This is the refraction. So don't wait for a new refraction. Don't fear refraction. You're good at refraction. Now the idea will be now to calculate refractive index n and whatever out. Anything to do with calculations. Remember, I said we are going to master it, so don't worry about it. It's not part of the things we worry about right now. Refraction, whatever, calculations, don't worry about it. We have to finish the theory. That is the deadly. That is the deadly one for us. If we're good at theory, we are fine, because when it comes to calculations as a team, we are all good. Okay, I'll make sure that you are good by the time you write. So are we good on refraction? So now we want to prove this. If it's in, let me just explain now. So here is where it becomes deadly now. Here is where it becomes deadly. I will explain it better when I teach you refraction. But here is when it becomes deadly now. You can have a rectangle. Let's just say this is air, and this rectangle is made out of glass. And then there is air on the other side. So now you're going to have your light ray come in like this, right? This is your first ray. It comes in like this. Okay, comes in like this. Comes in nicely like this. It gets to this. Right. We they want you to draw the path of this ray. That's the command. Draw the path of this ray. Now, obviously, if you are sketching, you need the normal line. So you come and put a normal line. Now, if it had continued, it would have continued like this. But here it's going to bend. The big question is how? Towards the normal or away from normal? I'll say to you, class, it's coming from air to glass. Which is more dense, air or glass? Glass is more dense, right? Yes, so it will slow down and bend towards the normal. So your ray is going to come out like this. So this is the first ray. Then you show it getting until it goes and hits like this. Now, guess what? It is at the boundary again. So you need to put another normal line. Now the question will be, how will it bend? Towards or away? It's now coming from glass back to air. Instead of continuing like this, how will it bend? Away from normal, right? So it's going to do this. So at the end of the day, this is the ray you will remain with. It bends like this. Can you all see? And this will be the end of your ray. Because it will bend away from normal. It's coming from more dense to less dense. It will speed up and bend away from normal. Question? Anyone with a question here? Who has a question? Now let's continue with how we talk about this experiment. Finish this experiment and we are done. Because we had started it. We really can't leave it in between. So anyway, I got carried away after teaching you about, after giving you the aim. So this is not part of the experiment. This is something else. When you do the experiment, I want you to write the aim. The aim of the experiment is to investigate how light bends. Everybody now knows it bends. When passing through a rectangular block, which is like this, then we'll do a semicircular block and a prism. We'll do more of them when we do refraction, but I just want you to prove this. So this is going to be the aim of the experiment. Now, let us put the variables. This is a this is a favorite question of exams. They love to ask about variables. What are the variables? First one is the independent variable. Is the independent variable. This is the first one. What is the independent variable? In brackets, I want you to say, what you change. The independent variable is what you change. And I want you to say, the shape of the block is the independent variable. We are going to be changing the shape of the block. Number two, the dependent variable. The dependent variable. Students, come on. Rise, rise, rise. You can do this. What is going to be affected? What you measure. What you measure is obviously what is affected by the independent variable. What is the shape of the block changing. We are testing refraction. So it is going to be affecting the angle of refraction, how much your light will bend. So the angle of refraction is the dependent, what we'll be measuring, variable. It's obviously the one that is being affected. That's the one we measure. Are we on the same page? Students, great. Let's go to the control variable. Things that change, but you are going to make sure that these things don't change. If these things change, you are in a lot of trouble, my friend. They shouldn't change. Number one is obviously the width of the beam. So the control variables, things to keep the same. Things to keep, make sure these things, you keep them the same. What is it? Number one is the width of the beam. The control variables are, you should study these experiments. Think about them. Look at them. Don't throw the book away. We are past that stage. We are hungry people. The control variables are one, width of the beam. Okay? And two, the light, the type of light. I said it yesterday, okay? So, in other words, you can say the wavelength and the frequency. If you change the type of light, you are going to change the wavelength of light and frequency of light. Have you seen this? Now we are at part 3, which is the apparatus. Right? Apparatus. In brackets say equipment. The apparatus, in brackets you say equipment, that we are going to use here. One, ray box. Okay, you can put them. Usually apparatus is put with dots like this. You need a ray box, which produces, the ray box is just something which produces narrow light beam. Okay, a narrow light beam. Okay, then you need protractor. You can see on the internet how to make a ray box or whatever, a homemade ray box or stuff like that. So you need a ray box and a protractor. Protractor which measures angles. You know, protractor is to measure the angles. Then we need a paper. Then we need a pencil. Then we need a ruler. But we don't need a mirror. We will need glass blocks. Okay? Why? To bend light. So it's pretty much the same thing as reflection, but the only thing is there is no mirror. We need a glass box. Okay? Paper is for drawing rays. For drawing rays. Pencil is for marking rays. Then ruler is for straight lines. Ruler is for straight lines. Are we together? Are you putting this simple stuff? Students, guys, are we together? Great. Let's finish it up. Right. Let's go now. The method. Let's go now. Let's go now. Part 4. Method. Part 4 is a method now. Let's put the steps. Number 1. I'll show you the diagram, right? I'll show you the diagram. Part 1. The first step is to place the glass block on paper. The first place the glass block on paper and draw around it. And draw around it. Place the glass block on paper and draw around it. Obviously, so we were going to place our... Okay, I'll put the diagram. Just let's put the steps first. Then number 2, you shine the ray box at the block, the glass block. Okay, your ray is now going to that glass block. Then number 3, you are going to mark points on the following. You are going to mark, just put an X, points on the following. 1, the incoming ray. You mark close to the ray box, okay? You put an X. On the if it's coming like this, you go on top of it, you just put an X like that. That's what I mean, okay? If the ray is coming like this, you go on top of it, you go right where it is, you just put an X on its position. Then the second thing, number 2, the entry point. Class, the entry point. Are you writing with me? Lehakwa, are you writing with me? LGK. Karabo, are you writing? The next point you mark? Hello? Good. Yes. All right. Entry point. 3, exit point on the block. 4, it's so easy. A point on the outgoing ray. You just put an X somewhere on the outgoing ray. Right. Then number 4, after marking this, right, you place these things, you shined the ray at the block, you marked the points, then now you should draw a normal line. Draw the normal. Okay? The 90-degree line. After you have drawn the normal, where on the block? Remove the block now. I'll show you. The normal, where there's your normal, right on the piece of paper to the block. You know that if this was my block, I have the normal here. Let's say this is the big paper here. I have the normal which gets to the block, and where the ray is coming out, I also have a normal here. So I should see normals here where the ray is coming in and when the ray is coming out. I want to see normals. I want to see those normal lines. So this is normal and this is normal. You draw the normal. But on the incoming ray, you put just an X, which you're going to use later on. And you have your ray box. The ray box, you leave it there. The ray box is never moved. Don't move the ray box, which is there. But you put an X where the ray was incoming. You put an X on it. You mark it. Then the outgoing ray, where it was, you instead of putting this, you just mark it like that. And the normal line is what you're going to put. So now you have this. You can now remove the block. And you are going to join lines. Okay? So if you remove the block, it gets to the normal. Then from this normal, it goes to this normal. Then from this normal, it goes like this. That's basically what we mean. You can do that. Come on. You know, you have this normal, you have this normal. So it goes like this to this normal. Then it bends to this other normal here. Then it bends through this point. You have drawn the path. You have shown the path of your ray. Come on, students. So, number 5 is to remove the block, which was here. You remove it. So number 5, remove block and join the lines. Number 6, measure angles using a protractor. There is this one. There is angle of refraction here. Then there is this incoming. Then there is the angle of refraction here. So we have those. Okay? Are we together? Measure angles. Okay, students? Now, what you will change is the way your ray is hitting onto the block. You may twist the ray box to maybe now hit like this or whatever. So repeat after measuring angles and stuff. Repeat for different angles and shapes. Repeat for different angles and shapes. Are we together? Students, are we together? Okay. So here maybe the question would be, okay, so do I have 4 angles for this experiment of refraction? When I'm trying to measure, I'm measuring the incoming angle and the angle of refraction, the incoming angle and the angle of refraction. How do I draw the results table for these different angles and then for the different shapes? Can you put me an example? This could be what you have. Huh? The questions that you could have, things like this. Let me try to now show you like we did yesterday, because yesterday after the method I then showed you an example of results that you must get, an analysis of results. So if we put an example of a results table, okay, we have of course the incoming angle, then we have the angle of refraction. So we are going to have the angle of incidence, incoming angle, then we have the angle of refraction in here in our block. We'll check angle of refraction here. So let me try to, let me see if I can fit a diagram for you. I kind of showed you already what the experiment is like. All you need to know to have is, maybe let me put the table first, then I'm going to put the diagram for you to be able to see what I mean and where you get these things, right? Are we together? Hello? Students, why are you quiet on me? If we put results, here is an example of a results table. So, let's just say you have, let's put angle of incidence is going to be I. Then you're going to have angle of refraction, which is going to be R. So we can say here, shape of block, maybe a results table. Put it like this, example results table. I'm just showing you some results. But of course, you're not going to actually perform this experiment. I'm just showing you what it would come out as, because you're just going to show to tell them how you set up this experiment. That's the question I showed you last time in the past papers last night. They won't ask you to actually show them the results or whatever, but a results table would be something like this. We'll have the shape of block, then we are going to have the angle of incidence, then we are going to have, this is your I, then we have the angle of refraction, which is going to be your R, something like this, right? And we say, okay, when the block, when we have a rectangular block, maybe you have a rectangular block, and it will be 20 degrees, and you can have a rectangular block as well. And you can now put 30 degrees or 40 degrees or whatever, 30 degrees, and you can have a rectangular block again. Don't make it too much. Don't make the angle too much. Keep it small. Keep them small. You can have 40 degrees, stuff like that. So here we have not changed the shape of the block. We are changing the angle of incidence for now. Now we can then change the shape of the block to then say, okay, what if I now have the shape of the block being a semicircular, okay? We can even get up to 50 degrees for those who wanted a rectangular block up to 50, right? You can still put your rectangular block. Then you get up to 50. Then you change now to be the semicircular. Then you can change to be the prism. Semicircular block, and you put it at 20 degrees. Then you put the semicircular block at 30 degrees. Then you put the semicircular block at 40 degrees. Then you put the semicircular block at 50 degrees. Can you see this? Semicircular block. Then you have again a semicircular block. Can you see this? Then you can put a prism and stuff. So this is how your results table is. Have you seen what the results table will look like, students? This is just an example of a results table, what it is going to look like. Anyway, so you'll be putting your things, and you can, if you are now here putting, for example, the experiment for those who wanted to see your diagram, you have your piece of paper. Oh, okay. Well done. You have your piece of paper, and you have the ray box, whatever here, wherever you put it, facing the inside. It's shooting rays into the inside here. The ray comes in, and you have your block, which we said you show us the whole thing. You draw around your block. Your block is like this. It's sitting here. This is the block. It hits onto the block. Okay. This is the hits onto the block. And what happens? Of course, you know it's going to bend 2 times. As it goes in, instead of going like this, the normal is like this. It will bend towards the normal. Then it goes there. It will bend away. Whatever, like this. Your ray. So, can you see this? So, most important angles, here starting this one. This angle of refraction here. Are we together? By the time it comes back, it will be back to 60 degrees again, to the same eye. So what we want is this R here. This angle between the normal line and your ray. This is the R, this is the I. Between the normal line and your ray. So this is the angle we want. That's the one you're going to be measuring. We'll see all that, okay? That is what you're going to be seeing. That's all you want to be checking. Are we together? This is just a sheet of paper here. This is a sheet of paper. I think I made it way too big. And then here is your ray box. And you can now put your pencil where you'll be marking, and you can put your ruler, and you can put your compass, you understand? So something like that. You put your protractor. Well done. This is O. You keep it like this, then you can have it. Well, what I needed to do was to show you how you then the errors, the sources of errors that you know, and the safety considerations that you must always have when you do this experiment. Those are the last things that I was supposed to show you. I don't know if I can write it in 5 minutes. Let's do it, because I don't want to have to do this again. Okay? Are we together? Let's put part 5. Okay, part 5 was results, right? Here, results, example of a results table and stuff. Then part 6 is going to be errors. I mean, I'll show you the different types of the what happens when you refract with a glass, with a rectangular block, with a prism, which is like a triangle, and what happens when you refract with a semicircular block. I'll just show you. I showed you with the rectangle already. So anyway, on errors, you must know, number 1, systematic error. The systematic error. Is a systematic error going to be brought by you as a person? No. It's from the device you use, right? So, error could occur if the wrong normal, is drawn, okay, the 90-degree line. How do you prevent against it? Prevention: use a set square. So that means there's another piece of equipment that is going to be needed. This experiment has a source of error. Well done. And this is how you can fix. What about random errors? What about the random errors? What about random errors? Students, what about random errors? Error could occur if what? Number 1, random errors. No, we're still under, it's the second thing here. Error could occur if the rays are not marked correctly. Okay? If the rays are not marked correctly. So if they ask you for sources of error, how do you prevent? Use a sharp pencil to rectify this error. Okay? Are we together? All right. Last 2. Error could occur if the protractor is not read correctly. So this is the human being causing these ones. Hey, if you don't mark the race correctly, you're going to create an error in this experiment. The values you'll be reading will be wrong values, and you'll not be able to prove what you actually want to prove. Hey, if you don't read the protractor, all my days, my iPad is flat. Ah. Whew, my days. I overused it today. Like I was just lesson since last night, eh? It hardly charged. So, sorry for that, guys. My iPad is flat. And I guess the lesson has come to an end 20 minutes before. Keep what I've done. Let me stop the live videos.